Alright, welcome to the video on number sets. We're going to be dealing with different kinds of numbers. This is outcome A2a. So let's just jump right in. Okay, so this might seem childish, but it is a childish start. We start off with something called the natural numbers. The natural numbers use a symbol n. It's a fancy n, so we have this double line over here. Getting all fancy on us, but really the natural numbers are the numbers that you know when you're a little kid and you're counting with Elmo over here. So it's the numbers 1, 2, 3, etc., etc. So when you count apples or cows or whatever it is that you count, you can use natural numbers. They're just the obvious numbers that you can see off your fingers. They're the numbers 1, 2, 3, and etc. On and on we go. Okay? Those are the natural numbers. Now, as you start encountering the world, you start to realize that there's a little bit more out there than just the numbers 1, 2, 3, 4, 5, and etc., etc. So the next level of things here is whole numbers. And Elmo did not see this coming here. You look, he had 1 and 2 and 3, but he's missing something. He's missing the number 0. So when we look at whole numbers, we'll use a fancy W, the double line W, and W, the whole numbers are the numbers 0, 1, 2, 3, etc. So we add in that nice little number 0. We can rewrite this, okay, so that the whole numbers are really all the natural numbers and the number 0. Okay, this little symbol here really does mean and. It's the symbol for union. It's a U for union. So the whole numbers are the natural numbers with a union with 0. Okay, next. As you get a little older, of course, you start to notice that there are other kinds of numbers that are out there. And the next category is integers. These are the classic number line that you see in junior high school, where you have negative integers like -6 and -5, etc. And you have positive integers, 1, 2, 3, 4, 5, 6. Oops. And you also have that number 0, which is neither negative nor positive. Okay, so we can write out the symbol for integers is very interesting. It's a Z. Okay. Some people think that this comes from the French for Z integers, but it's actually comes from German. I can't remember the word off the top of my head right now. But the symbol is Z, and it's all the numbers ... -2, -1, 0, 1, 2, etc. So the integers go off in both directions. It's all the positive natural numbers and the negative natural numbers. Still, as you get even older, you start to get guys like this, these really cool people we call math teachers. And they'll start to tell you about the numbers that fall in between on this number line. So rather than dealing with the numbers like 1 and 2, there are numbers that fall right in between there, like 1.5, or the number 7/5. Now there's infinitely many numbers, in fact, that fall in between. And we call all the numbers, including the integers and all the fractions and decimals and percentages that you can draw, we call them the rational numbers. Now, the symbol for the rational numbers is Q. Okay, now why is the symbol Q? That's the word quotient. So here we go. Here's how we write it out nice and formally. The rational numbers are the numbers that can be written as A over B, as a fraction A over B, such that A is an integer, B is a natural number, and we have one other stipulation. B is not 0. Okay, now that B not 0, that just means that we can't divide by 0, right? We can't have a 0 on the bottom of our fraction. Now we need to add to the rational numbers here. We should clarify that The natural numbers are all fractions, like 1/2 and 2/3 and -4/5, and also the number 2, right? Because 2 is really just 2 over 1. But also, we can rewrite rational numbers as decimals. Okay, so in decimals, any decimal written like this, for example, 0.25, that's a rational number. Okay, and a number like that is called a terminating decimal. When we have a decimal that's terminating, that means that that number can be written as a fraction. The alternative to terminating decimals are something like this, 0.33, repeated. That will go on forever, infinitely long string of threes. But it does repeat itself. So we call this a repeating decimal. Okay, and this number can also be written as a fraction. In fact, the first number, we could write that as 1/4, and the second number is 1/3. Okay. Now, later on, as we got a little bit more advanced, we started to notice there were even other numbers in between. The famous irrational numbers. Now, you haven't seen very many of these coming into grade 10. You do, of course, know the most famous irrational number of them all, pi, which you enjoy eating. It's a nice snack food, as well as being a number that you use in circles and trigonometry and things like that. Okay, so what is an irrational number? Well, it's really kind of hard to define, but perhaps we could say this. An irrational number is not rational. And we can rewrite that. There's a symbol for that. We write like this. It's not rational. Okay, so what kind of numbers are not rational? Well, they're strange. They are decimals that are non-terminating. In other words, they never stop. They go on infinitely long, forever and ever. After 1 billion decimals, you still have infinitely more to go. After 1 trillion decimals, you still have infinitely more to go. But not only are they non-terminating, they are also non-repeating. So even after you've done 1 billion decimals of a number like pi, you still have never found a pattern that repeats itself. These are very strange numbers. Now, oddly, these numbers are more common than rational numbers. Okay? It's strange but true. And you'll see a lot more of irrational numbers as we move forward in this course. Just as a preview, the kinds of irrational numbers we'll see in the course are things like the square root of 2. That one's irrational. It cannot be written as a fraction. The square root of 3 is also irrational. That cannot be written as a fraction. But guess what? The square root of 4, that's really just the number 2, and 2 is rational. So the irrational numbers are it would include all the square roots of non-perfect squares. Okay, and you can ask more about that from your teacher. Next, let's sum it all up. We've got something called real numbers. Okay, real numbers is the set of all numbers that are out there. Real numbers are written with the symbol R, and R is all the rational numbers and the union of that with all of the irrational numbers. So all the numbers combined together. Okay, every number that you've ever seen or dealt with before is real. And the real numbers fall within either one of two categories. They're either rational or they're irrational. And subcategories of the rational numbers include the integers, the whole numbers, and the natural numbers. And the way we've designed this little graphic that you see really does explain how things work. All the natural numbers are also whole numbers. All the whole numbers are also integers. And, well, all the integers are also rational.